everyone. Today we're going to be talking about circadian rhythms and how our body maintains a sense of time and sleep. So our body has an internal clock that regulates the biological functions and processes within our body, called the circadian rhythm, which is a cycle that runs roughly on a 24-hour basis. A specific part of our brain, called the suprachiasmatic nucleus, which is a pair of nuclei in the hypothalamus, is responsible for the circadian rhythm in a large part. If you remember from previous videos, the hypothalamus is a region of our brain that keeps our body in a state of balance or homeostasis by regulating the release of hormones throughout the body. The suprachiasmatic nucleus within the hypothalamus is like a metronome that allows our body to have a sense of time. In a very simplified version, you could imagine that the suprachiasmatic nucleus is basically sensing that, okay, now it's nighttime, so I should go to sleep, and vice versa. Now it's daytime, so I need to tell the body to stay awake. But how does this SCN, or suprachiasmatic nucleus, actually accomplish this? The SCN produces CLK, or clock proteins, that accumulate during the day and activate the genes that keep us alert and awake. The clock proteins also produce pair proteins, and as the number of pair proteins increases to a certain point, after the day is over, they will deactivate the genes that were keeping us awake, allowing us to fall back asleep. The genes that regulate our circadian rhythm are called clock genes, and were first discovered in the Drosophila melanogangster, which is the scientific term for a fruit fly. This animal is important in several neuroscientific discoveries, so I would remember the scientific name, Drosophila melanogangster. However, the genes found in these flies were discovered to be nearly identical to those in mammals. Our SCN does not only keep track of time throughout the 24-hour circadian cycle by itself, but light signals from the eye also help it discern the time of day. In fact, without light signals, the CLK proteins will lengthen the circadian rhythm to slightly over 24 hours. But light signals from the photoreceptors in our eye help shift the SCN back on track. The SCN, or suprachiasmatic nucleus, also alerts another part of the brain called the paraventricular nucleus, or PVN, to communicate to the rest of the body whether the body should be alert or asleep. The PVN then tells the pineal gland to release more or less melatonin, a hormone that reduces alertness and increases sleepiness. Generally, light inhibits melatonin secretion, explaining why we are normally awake in the day and asleep at night. Bright screens can actually trick our circadian rhythms, since our body receives light signals from the screens and starts to believe that it's actually daytime even when it's not, which is why binging TV at night can decrease your melatonin levels and make it difficult for you to fall asleep. Ventricular nucleus, or PVN, to communicate to the rest of the body whether the body should be alert or asleep. The PVN then tells the pineal gland to release more or less melatonin, a hormone that reduces alertness and increases sleepiness. Generally, light inhibits melatonin secretion, explaining why we are normally awake in the day and asleep at night. Bright screens can actually trick our circadian rhythms, since our body receives light signals from the screens and starts to believe that it's actually daytime even when it's not, which is why binging TV at night can decrease your melatonin levels and make it difficult for you to fall asleep. Now, what happens when our circadian rhythm is out of sync? Well, first let's think, when would this happen? When would our circadian rhythm be out of sync? Well, think about jet lag. When your body is in a different time zone, your brain is running on a 24-hour schedule that contradicts the 24-hour schedule at your location, so your body has to deal with a circadian rhythm disturbance. For instance, if you normally live in California, which runs on Pacific Standard Time, and you travel to a country that is 10 hours ahead of Pacific Standard Time, at 5 p.m. PST, you're normally up and about. But once you're in that new place, 5 p.m. becomes 3 a.m. When it's dark outside and when you're supposed to be asleep. Even though your body detects the absence of light, it cannot immediately switch its biological clock to fit the new time schedule of your new location. So your melatonin levels are probably too low to allow you to sleep at that time, at 3 a.m. And this disturbance in the melatonin levels and in your sleep cycle will continue for a few days, and that's why it's very difficult for you to sleep when you're supposed to once you're traveling to this new location. Jet lag normally only lasts a few days, But what happens when your circadian rhythm is out of sync for a prolonged period of time? You actually will run an increased risk of weight gain, insomnia, depression, and even cancer. Not everyone's circadian rhythms operate on the same 24-hour basis, however. You're probably familiar with the common distinction between an early bird, someone who feels that they work best in the morning and wake up early, versus a night bird, who feels more alert later on in the day and goes to sleep at what we consider late at night. Schools in America normally start before 8:30 a.m., which can actually cause circadian rhythm disturbances for the students who are night owls and whose circadian rhythms lead them to fall asleep later at night. For instance, students whose melatonin levels peak at 1 a.m. may only be able to go to sleep around 1 a.m. But if they need to already be at school at 7 a.m. for zero period, they would be at an absolute maximum of 6 hours of sleep, causing them to wake up earlier than their circadian rhythm would actually allow them to, and also causing sleep deprivation. In turn, the circadian rhythm disturbance and sleep deprivation would lead to increased health risks.